Hello everyone, my name is Arohi and welcome to my channel Code with Arohi. So in this video, I will tell you what are Style GANs and how Style GANs are different from the traditional GAN networks, right? So let's begin. So before moving to Style GAN, let's just see an overview what GAN networks are, right? So in GAN networks, in every GAN network, there are two important components. One is generator and the other one is discriminator, right? These two networks you'll get in every GAN network, discriminator and generator. What generator does? Generator generates a fake image from a random noise, right? And discriminator tries to distinguish between the fake sample which is generated by generator, tries to distinguish between this fake sample and the real sample. Real sample, discriminator is getting this real sample from our training data, and this fake sample from where it is getting this fake sample? From generator. And the task of discriminator is to distinguish between the real sample and the fake sample, right? And as the training progresses, both generator and discriminator, improve, right? Means after every epoch by epoch, as training progresses, both the network becomes smarter. Generator getting smarter at generating fake images which looks real enough to fool discriminator, and discriminator is getting smarter to detect between the fake sample and the real sample. This is how this GAN network works, right? The traditional GAN network works. Now, let's see what is StyleGAN and what is new in StyleGAN. So, StyleGAN is basically an open source project by NVIDIA. And this link, you can see this paper. In this paper, research paper, this particularly the StyleGAN was established by a research paper. Okay, so now what is new in StyleGAN? So the very first thing is the architecture of generator, right? So in GANs we have generator and discriminator. So the architecture of generator is different in StyleGAN, right? In GAN there is different kind of generator, right? Architecture of generator in GANs are different, but in StyleGAN the architecture of generator is different. So I'll tell you what is that difference and why that different, why they made a new architecture for generator. Let's see that. So these are the new things in StyleGAN. So the very first thing is in StyleGAN is it is progressive growing. Don't worry guys, if you are hearing these terms first time, like what is progressive growing, noise mapping network and adaptive instance normalization, don't worry, in my today's class I'll explain you all of these things with a proper example, and I'll teach you these concepts in a way as you are a beginner. Okay, so don't worry about these topics right now. I'm just writing down these things because I'm telling you like these are the new things which got implemented in StyleGANs. But what these things are, now let's discuss those things. Okay, so the very first thing is progressive growing. StyleGANs are progressive growing. Now what are progressive growing? Okay, so let's see that. See, StyleGANs use progressive GANs as a baseline. So there is a kind of network, GAN network called progressive GANs, and StyleGAN network use progressive GAN as a baseline. Now what are these progressive growing GAN networks are? So progressive growing GAN network simply means you consider this image, see this image. So the very first image is of a very low resolution. The resolution size over here is 4x4, right? So this is a very low resolution image. And then we have an image of resolution 8x8. And then we have an image of resolution 16x16. After that, we have an image of resolution 32x32. And then we have an image of 64x64. So what I'm trying to say over here is, initially, progressive GAN networks are network which starts the training process with the very low resolution. Okay, so in StyleGAN networks, we will start our network with a very low resolution image which is of size 4x4. So now why we are using this low resolution image over here. So low resolution image simply means we want to train our algorithm on a very simple problems first, right? So once our algorithm will learn the simple problems, it will be easier for our algorithm to learn complex problems, right? So complex problems means high resolution images, and this simple problem simply means low resolution image, low resolution images. So once your algorithm learn how to handle low resolution images, then it will be easy for an algorithm to learn how to handle complex problems, how to handle high resolution images. This is what progressive GANs are. Progressive GAN simply means we want to teach our algorithm on simple problems first. Once our algorithm get proper training on simple problems, then we will train our algorithm on high resolution images, means we will train our algorithm on complex problems, which is high resolution images. So what we want is we want to evolve the training process very slowly, right, in order to train our algorithm properly. So this is what progressive GAN. So you can consider this image over here. So layer by layer we will upsample the image. Upsample the image simply means over here we have an image of 4 into 4 resolution. So this is a very low resolution. In the next layer we are having an image of resolution 8 into 8. So we upsample the 4 by 4 image into a 8 into 8 image, and then in next convolutional layer we upsample that image to a 16 into 16, and then again in next layer we upsample our image to a 32 into 32, and we started with this low resolution and we end up with this resolution layer by layer, right? And what we are doing is we are following the process of progressive GANs. Simply means we start from a low resolution image and we are training our algorithm on a simple problem first, and then layer by layer we are increasing the upsampling, we are performing the upsampling, we are increasing the resolution, and we are getting this output. So this is what progressive GANs are. Okay, so now over here, as I just told you, we are upsampling the image. And now how we are doing upsampling. So guys, if you have checked my video on GAN networks, right? So if you are new to this video, then in description section, I have given a link of GAN networks also. You can check that video. In that GAN network video, I have told you that we use that transposed convolutional layer for upsampling, right? So in traditional GAN networks, how we do upsampling? We are doing upsampling with the help of this transposed convolutional layer. Okay. But in style GANs, we are not using transposed convolutional layer for upsampling, right? So we are doing upsampling like right layer by layer. From 4 by 4 to we are getting 8 by 8. From 8 by 8 we are getting 16 by 16. So we are doing upsampling, but we are not doing upsampling using transposed convolutional layer. We are not using upsampling, doing upsampling using this layer. Then how we are using upsampling in style GANs? We are using bilinear sampling. Now, why we are using bilinear sampling, right, instead of that transposed convolutional layer sampling? So the reason for that is, just check this image. For example, you have an image, let's say this is just an example, okay? So let's say you have an image of size 64 into 64. That means you have 4096 pixels in total. Now, you want to upsample this image from 64 into 64 to 256 into 256, right? So right now, the image size is this, but you want to upsample this image from 64 into 64 to 256 into 256, right? So that means these are the total number of pixels you want right now, but earlier you were having these pixels. So now the question over here is, you know the value of 4096 pixels, but right now after upsampling you have 65,536 pixels. Now, from these pixel values, you know these many 4096 pixels value, but what to fill at other pixels location, right? So see this picture. So let's say 1, 2, 3, 4 are the 4 pixel values, and this is what you are doing at upsampling. You know the 1 pixel value is 1, other pixel value is 2, 1 pixel value is 3, and the other pixel value is 4. Now you are doing upsampling. You don't know the values, what to fill over here. What are the pixels value you want to fill over here, right? You need to fill some values, then only you will perform the upsampling. So earlier in GAN networks, we were using transposed convolutional layer, convolution for upsampling. That means we were using nearest neighbor, nearest neighbor sampling. Nearest neighbor sampling simply means it will copy the value from the nearest pixel. If this pixel is near to it, it will fill 1 over here. It will copy the pixel value from the nearest pixel and will fill it. Okay, this is what that transposed convolutional does. But in StyleGAN, we were using bilinear sampling. Bilinear sampling simply means the places with the zero filled, we are how we are getting the values of these pixels. So what we are doing is we use all the nearby pixel values, right, to calculate the pixel value using linear interpolation. Means we are not only considering the one value, what we are doing is we use all nearby pixel values to calculate the pixel value which we want to fill over here using linear interpolations. This is what bilinear sampling is, right? So in StyleGANs, what we are using? We are using bilinear sampling. Why we are using bilinear sampling? Because the technique of choosing the right pixel values, the way of choosing a right pixel value in bilinear sampling is more, we are doing more calculation over here and we are getting more good values, pixel values. So this is the second difference, bilinear sampling. And what I've told you, the first one is we are using progressive GANs. Progressive GAN simply means we are initially starting with a low resolution image. And then we, layer by layer, we perform upsampling. And for upsampling, what we are using bilinear sampling. Okay. So now let's see what's next. Next thing which is new in StyleGAN is removal of this thing. So guys, in traditional GAN networks, if you remember, a network starts by taking a random noise which is of 100 into 1 noise vector size. So this is a 100 into 1 noise vector size. We reshape it and we then give it to our network. So this part is removed in StyleGANs. Instead of giving this random noise which is of 100 into 1 vector size, what we are doing is we are starting our network with the constant size of 4 into 4 into 5 into. So 4 into 4 simply means, as I've told you, StyleGANs are progressive GANs. That means we initially start with a very low resolution image, and by default StyleGAN use 4 into 4 into 5 into. The very first image size which it picks is of this size, 4 into 4, right? So this is a low resolution image, and layer by layer we will upsample our algorithm, right, to reach the good results, to reach here. So initially we start with this resolution, right? Because why we are using the low resolution, as I've just told you, we are using the low resolution at the initial point because we want our algorithm to learn the simple problem first, to learn the low resolution images first. Once it learns the low resolution images, once it learns the simple problem, then we will upsample the image at every next layer to we will upsample it to get the high resolution image. Okay. So this is the another change in StyleGAN. What is the change? Remove this, and at this place what we do is we will be using a constant matrix of size 4 into 4 into 5 into. Okay. So this is the another change. All right. So the next is mapping network. So remember in the beginning of my today's class, I've told you there are the three major changes. And the first one is progressive growing. This I've explained you. Second is noise mapping network. So now I'm telling you what is noise mapping network, right? So yeah, this is a noise mapping network. So guys, if you remember the traditional GAN network, so this is the picture of traditional GAN network. So what we does is we have a random noise in the beginning and we give this random noise to our network. So this will go to the very first convolutional layer, right? And the output of that convolutional layer will become the input to next convolutional layer. This is how a network works, right? So what happens is as we go deeper in the network, the role of this random noise diminishes, right? So in StyleGAN, we don't work in this way. We don't give the random noise like this. So for that, we have a mapping network. So what this mapping network is let's discuss that. So this mapping network is a 8-layer multi-layer network. This is basically we have 8 layers, fully connected layers in this network, right? So this is a mapping network and we have 8 layers over here. And this is the vector with 5 and 2 dimensions, right? So this is a latent vector Z, let's say. So this vector will go to a mapping network where we have 8 layers, fully connected layers, and finally we will get a output of a dimension vector with a dimension of 5 and 2, right? And let's say this is the W. Over here this latent vector is Z, and over here the output of mapping network, let's say we are getting W over here. Okay. Now what we want is this W means the output of this mapping network will become, this W will go to each convolutional layer of generator. Okay, let me show you how. See, in traditional network, what I've told you is this random noise goes to the very first convolutional layer and the output of that layer will become the input to next layer, and as network goes deeper, the role of that random noise diminishes. To overcome this problem, we need that random noise to, go to each convolutional layer. So for that, we have a mapping network, and mapping network have 8 layers. Each layer is connected with other layer, and the output of this mapping network will be this W. The size of input to the mapping network and the size of output of this mapping network is same, 5 and 2 into 1, right? Vector with 5 and 2 dimensions. Okay. Now, what is going on next? Let's see. So this is the mapping network which I've shown you in the previous image here. Now this is a more defined image. So this is the mapping network which I have explained you. The output of this mapping network is going to each of the convolutional layer which is present in our synthesis network, means generator. Synthesis network and generator is same. Okay. So the output of this mapping network is going to all the convolutional layers which are present in our network. And in StyleGAN, the synthesis network have 18 convolutional layers. Over here, I'm just showing you less number of layers because I just want you to explain the concept. But in my next slides, I'll show you all those 18 layers. Okay. So this synthesis network or generator have 18 convolutional layers, and we have 2 convolutional layer for each resolution, and we initially start our network. Generator will start by 4 into 4 into 5 and 2 because this is a low resolution image, and StyleGAN uses progressive GANs as baseline, so that's why we are starting with a very small resolution. And for every resolution we are having 2 convolutional layers, and to every convolutional layer we will give this latent vector which is of size 5 and 2 dimension, right? Vector with a dimension of size 5 and 2. Okay. While giving this latent vector W to every convolutional layer, we have this A in between. What this A is? This A is a learned affine transformation, right? This W will pass through this learned affine transformation before going to ADA in. What is this ADA in? I'll explain you that also. Right? Basically, what I'm saying over here is the input to this ADA in is a style image which we will be getting, right? Once this random noise, this latent vector will go to this learned affine transformation. When this random vector will go through this, we will get a style image. Okay. So basically what I'm trying to say over here is that this encoded, from over here we have a encoded mapping, and we are converting this encoded mapping into a style image. And how we will be getting the style image? When that encoded mapping will pass through this learned affine transformation, that encoded mapping will convert into a style image. That style image will become the input to ADA in, right? So every ADA in will have two input. One is a style image, which we are getting from this A. And what this A is a learned affine transformation. And what is the task of this learned affine transformation? This will convert the encoded mapping which we get. This is encoded mapping. It will convert this encoded mapping into a style image. That style image will go to ADA in, and the output of this convolutional layer will also go to ADA in, right? So ADA in is getting two inputs. One is the style image, one is the feature map from the convolutional layer. Then we'll apply this style on that feature map. Okay, this is how it's working. And we have another thing you can see. See, A is going to ADA in, and the output of this convolutional layer is also becoming the input to ADA in. But before giving the output of convolutional layer to ADA in, we are adding a Gaussian noise in it. This B is a Gaussian noise, and we are adding this Gaussian noise to a feature map before giving that feature map to ADA in. Now, why we are giving this? Why we are adding this Gaussian noise? This is for style variation. Okay. So you can study more about it. Basically, we are adding Gaussian noise. We are adding some noise on a feature map for style variations. Okay. So now, how we are working is, okay, let's move to the next image. There I have explained these things in more detail. Okay. So, as I've just told you, how many convolutional layers we are having in this synthesis network in generator? 18 layers, right? How we are getting 18 layers? So we start our image from a very low resolution, which is a 4x4, and our final layer will have a image of size, high resolution image of size 1024 into 1024, and for every size of resolution image we have two convolutional layers, and this is what it looks like. Okay, so this is the first block. Initially our image starts with this low resolution image. We have an ADA in and convolutional layer and ADA in. So this is for 4x4 resolution. So we have two convolutional layer for it. And then again for next resolution, which is 8x8, we have two convolutional layer, and after every convolutional layer we have ADA in, right? In the same way, this is for 16x16, and in the same way we have two convolutional layers for 32x32. In the same way we will, the similar code will work for all these, right? This is how this generator works. Now let's discuss this image in more detail. So this is our mapping function. So this mapping function I have already explained you. We are giving this Z, a vector of 5 and 2 dimension, to this mapping network function. We have 8 layers over here, and the output of this mapping function will be 5 and 2 into 1 only. This is W. Let's say this is a W. This we will add to every convolutional layer. Okay, in traditional GAN network we don't do this thing. This is new in style GANs. So now we want to add this latent vector W to every, at every convolutional layer. So that is what I'm doing. See this black line. So this is going to this layer also, this layer also, every layer. And we are adding we are using learn defined transformation in between. Why? Because right now over here we are having a encoded mapping. We want to convert it into a style image. So this learn defined transformation will convert into a style image. That style image will go to EDA in after every convolutional layer. Now the output of convolutional layer will go to EDA in, and the another input to EDA in will be the style image which we get from learn defined transformation, right? When we applied this A on this W, and then we get this style. That style image is going to EDA in, and the other input to EDA in is a feature map from this convolutional layer. But before giving that feature map of convolutional layer, we are adding a Gaussian noise in it. Why we are adding Gaussian noise? Because we for style variation, right? So in the same way as I've just shown you this A and B over here, in the same way we will give A and B to the other layers also. This is how this mapping network and synthesis network work. So guys, this is what style GANs are, right? So I'll discuss, in my next class, I'll show you the practical implementation of it. But I hope you understand what is new in style GANs, right? So, what is new in style GANs? Just to overview it. So, we have done few things, right? First of all, we are using progressive GANs as baseline. So that simply means we are starting with a very low resolution image, and then we will upsample our image layer by layer. And after that, for upsampling, we are using a bilinear upsampling, and we are removing this random noise from the beginning, right? And what we are feeding to our network generator is a constant image of size 4 into 4 into 512. And after that, we are using a mapping network. Why we are using a mapping network? Because what we want is we want to give that random, we want to introduce this random noise to each convolutional layer, right? But in traditional network, what happens is this random noise gets diminishes as our network goes deeper. So in style GANs, we give this random noise to each layer, and A is every time we want to pass this latent vector, it will go through this A learn defined transformation. This is again a new. We are adding a Gaussian noise. So these are the changes which are there in style GANs. So guys, in my next video, I'll show you how to implement style GANs in a practical way, right? So hope you like my video. Thanks for watching.